Today on Capeggi's Corner, we are going to look at some more proofs involving parallel lines. Our first proof for today tells us that segment BE bisects angle DBA. We also know that angle 3 is congruent to angle 1, and we are trying to prove that segment CD is parallel to segment BE. Now, if we start with our first given, segment BE bisects angle DBA, this is this angle right here, then we know that angle 2 is congruent to angle 3, and that is because definition of an angle bisector. Let's go back and look at our other given. Angle 3 is congruent to angle 1. Again, that's given. Now, if I'm trying to prove that this segment here, right here, CD, is parallel to segment BE, I notice that 1 and 2 are alternate interior angles. So if I can prove that they're congruent, then I can say that those lines are parallel. Well, if I look at my previous steps in my proof, I can actually get to angle 1 is congruent to angle 2. Now, the way that those steps are written, that makes that transitive. That's a transitive property. So from here, because angle 1 is congruent to angle 2, I can go to my final step, my proof statement, segment CD is parallel to segment BE, and that is because if two lines are cut by a transversal, and alternate interior angles are congruent, then the lines are parallel. In our next proof, the given information is angle 1 is congruent to angle 4. We know that lines A and B are parallel, and we're trying to prove that lines C and D are parallel. In trying to come up with a plan, I know that I have to get C and D parallel, so that's these two lines right here. And I notice in looking at 3 and 4, they're same side interior angles. So if I can somehow prove that I can add them up to 180, then I can prove that lines C and D are parallel. So I just have to figure out how I'm going to do that. So I have angle 1 and angle 4 already in my proof, the fact that they are congruent. So let's mark that angle 1 and 4 are congruent. I also know that lines A are parallel to line B. So when I see that, I know that I can say that angle 2 is congruent to angle 3 because they're alternate interior angles. So the wording is going to be if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Now again, going back to my plan, I'm trying to get angle 3 and angle 4, see if I can get them to add up to 180. Now I can't get there quite yet, but I do notice that I can say the measure of angle 1 plus the measure of angle 2 is equal to 180 because they form a straight angle, and that reason would be angle addition postulate. Now I can look, I have a double substitution I can do. Actually, I'm going to use this right here and that statement right there. But the only thing is this statement in angle 4, 1 and 2 are equal to 180 is equality, and those other statements are congruency. So I realize now during my proof I need to go back and add that. Measure of angle 1 is equal to the measure of angle 4, and measure of angle 2 is equal to the measure of angle 3. And that sometimes happens during the proof. I realize that I need to go from congruency to equality. Now, some books make you do that in separate steps, but we just do that all in one. So from here, I'm going to do almost a double substitution. So I'm going to say the measure of angle 4 plus the measure of angle 3 is equal to 180, and that is going to be substitution. Now I can say angle 4 and angle 3 are supplementary, and that is because of definition of supplementary angles. Now from there I can go right to my final statement. I know that lines C and line D are parallel, and I can say that because if two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel.